you guys so much for coming. My name is Emily, and I am part of the Google Maps API's deployment team. And basically what that means is that I work with our customers and users of the Google Maps APIs to make sure that they get the most out of the APIs, whether that's building a store locator or doing really heavy-duty analysis on data. And not only kind of like making sure that they're using them in the best way that they can, but employing development best practices, making sure that they're not doing something wrong with them, or making efficient use of them. And so we're going to kind of touch on all those areas today. Let me grab my clicker. So first of all, I don't know if you've been to some of the other Geo sessions today, but we'll talk a little bit about what are the Google Maps APIs, especially the web services. So a lot of people think of Google Maps and they think of like looking at a virtual map. But we're going to talk about what's beyond the map. And we're going to talk about why that matters for your businesses. We'll talk about a little bit the things that you can do with the APIs, with the web services. And then we'll go over the Cloud Console. So the APIs are part of the Cloud Console. If you've been to console.developers.google.com and used API projects, they're right there at your fingertips. So we'll actually go in and show you how to get started using them. And then we'll go over those development best practices. So a little bit nitty-gritty, how to use them in the most efficient way, some of the things to watch out for while you're developing using them. So first, what are the web service APIs? Specifically, they're HTTP services that you can use to actually request data from Google's enormous pool of geodata. Whether it's directions from point A to point B, or information about a place, maybe like the opening hours of the Starbucks across the street, or the elevation of a certain point above sea level. It's basically a way for developers to access and use that rich contextual location data. And something that kind of like, I personally am kind of like a Google Maps nerd because I just think they're really cool. So when I got the opportunity to like join this team about a year and a half ago, I really enjoyed developing using them because when you're using a product that uses the Google Maps APIs, you already know how to use it, right? Like, who in this room uses the Google Maps consumer products, like the website or the iOS or Android apps? How many of you came here using that in some form? Either the Google Maps, like actual app, or Uber or Lyft. Probably everyone. I did. So that's something that I think is really cool. You don't think about like how to get from point A to point B, and you don't think like, oh, is this wrong? When you look up a location on Google Maps, like you trust it. There are just millions, it's a stat here, 2 million apps and sites that use the Google Maps APIs. They're one of the most widely used APIs out there. Over 1 billion developers on a monthly basis use the Google Maps APIs, and they're really easy to use. They're easy to start using. We'll kind of go over, it'll literally take 10 minutes from creating a project to starting to actually request that data from Google. And like I said, users trust the data. So you don't think like, oh, this is probably wrong, or you don't open the Google Maps app or Uber and expect that map to not work or not be up to date. They're really comprehensive in that way. So now why are you here? You're here for using cloud and cloud products to enrich your business. So what are some of the ways that you can use this location data to actually get value and add that value to your business? How can you use it to enable your location strategy? We have so much data that can provide context and allow you to basically create new business models around this type of data. Sorry, my earrings are hitting my microphone. All right, so let's go into some kind of like high-level ways that you can use these Google Maps web services to enrich your businesses. Location intelligence. So have you, show of hands, how many of you have been to some of the Geo sessions earlier today? All right, that's actually great because this may be the first time you're seeing this. We've been talking a lot about location intelligence. Location intelligence is really just using location data, both just point data and context data, to draw insights into the physical world around you and how it's laid out, how it's changing, and how that relates to the business data that you already have. how many of you have businesses that sell something? I know that some of you are just not raising your hands because we all sell stuff, right? Whether it's services or goods, everybody sells something. And when you're selling something, especially e-commerce, you're taking in massive amounts of location data already. You're taking in addresses that can be used to provide context around analytics. So just as an example, if I'm in e-commerce, let's say that I'm Amazon.com, or let's say that I'm a smaller bakery shop that sells donuts and coffee, and I have riders deliver them to, let's say, people on their commutes in New York City. I take in those addresses where those people are ordering donuts and coffee, and if I can translate that into coordinate data in a usable fashion and analyze it, I can really draw powerful insights into maybe where I can plan business expansion, or where I have the most profitable markets, or maybe where I have gaps in my service. You can draw really powerful analytics around that, or maybe where I need to advertise more. That's something that's applicable across all industries. Risk analysis. So just as another example, if I'm an insurance company, I take in address data every time a user purchases a policy from me. And that address data can really tell me a lot about the kind of policy that I should write for them. What are my riskiest zip codes? Are users more likely to get into traffic accidents if they live within a certain proximity of a traffic circle or a freeway? How about just one neighborhood versus another neighborhood? Are they riskier? This is really, it's already there. The data's already there. And using the Google Maps Web Services to provide that location context can allow you to draw those new insights. Resource accessibility. So this is a huge one, and it's kind of like a weird thing to be passionate about, but there's 23 million people in the US that live in food deserts. This is like trivia. Anyone here know what a food desert is? You in the middle. Exactly. So it's limited or no access to healthy food choices like fresh fruits and vegetables. And you're right, it's usually in cities. And you think, well, it's so easy to find places in cities. It's really a public health problem, right? Like, it's a real big problem. And if you're a nonprofit and you can actually use location data, especially from the Places API, which actually there's a talk that's entirely focused on the Places API tomorrow, but you can basically use point data to gather really rich context, like what is that point? Is it a business? Is it a home? Let's say it's a grocery store. What are the reviews on that grocery store? What are imagery that we can gather from that grocery store? Are there fresh fruits and vegetables available there? You can actually use this contextual data to identify resource accessibility in certain areas, right? And so not only grocery stores, but this can apply to hospitals, let's say something a little bit less public health related, gyms, right? Like there's no gym within a 10-mile radius. You got like a serious business opportunity there. So yeah, the resource accessibility is a really huge thing that can be done using this contextual location data. Movement optimization. So when I think of movement optimization, I think of it as kind of like the next generation of navigation. Everybody knows, like, okay, you can navigate from point A to point B using a bunch of different mapping services, right? But we're not just talking about navigation, we're talking about real analysis around the movement of objects in the world. Businesses all have assets that they care about, whether it's people. Accenture is here at this conference. I think there's like 500,000 people that work for Accenture, right? Those are their assets. They need to know how they're moving around the country and the world. If you're a trucking company, right, you need to know how those trucks are moving and the efficiency of them. Our recent Geo talk, we just talked about smart vending machines, right? We have this massive Internet of Things that basically like allows us to know where things are in the physical world and how they're moving, and that can be really useful in drawing insights into your business operations. We'll talk about kind of the APIs that you can use to enable these things, and tomorrow there is also a talk specifically on the geolocation API. This is a really cool kind of like maybe lesser known API that Google has. It allows you to pinpoint the exact location of Wi-Fi or Bluetooth enabled devices like my fitness tracker here, that don't actually have GPS capability. And it uses triangulation using Wi-Fi towers and MAC addresses. But you can basically track the location of anything, right? Like anything in the world. So real-time navigation. Getting from point A to point B is really important, but now we can do that even better, right? We have predictive traffic time that allows you to pinpoint to within a 10-minute window, let's say, when your pizza is going to arrive. Probably 5 minutes or something like that. But like if you're moving a person from Williamsburg to Manhattan, or whether you're moving diamonds from San Francisco to Seattle, it's really important to make sure that you're taking into account road conditions, and you're taking into account traffic, and you're taking into account maybe anticipated like volume of those kind of routing problems. Basically, like the minutes that you can save using that predictive traffic time, historical and current, translate into real dollars. And routing algorithms. So if you've heard of the distance matrix API, I always kind of refer to the traveling salesman problem here. How can I move my items from point A to point B to point C to point D, maybe not in that order, but in the most optimized way? So you can use the distance matrix API to really optimize the movement of your items across the world. Location intelligence. This is something also that can apply to every industry. Location intelligence can address the better understanding of the daily changes and activities in our physical world. Oh, this went back. Oops. Connected devices is where we should be. We've been talking about connected devices a lot, the Internet of Things. Everything is connected now, right? Like, you probably have 5 items on your person right now that have some kind of internet connection, or are able to basically be tracked in the real world. This can be, actually I was just talking to someone who's here. There you are. Yeah, so we were just talking about this exact use case, geofencing. If you knew that you had a certain volume of potential customers at a certain time of day that were within a geographic area of, let's say, your physical store, you can tailor your advertising and marketing to them, you can tailor your staffing needs, you can tailor your inventory even, just by tracking the location of either devices or people to within a very, very high degree of accuracy. The Internet of Things, I think the prediction, I'm going to look at this prediction, I want this number to be right. 40 billion connected devices by the year 2020. That is a huge amount of connected devices moving around the world in real time that you can use to drive business analytics. Yeah, so cross-industry, and I know that there's people here from just so many different industries. These things apply to everybody. It's absolutely across industries. Location data can drive business value. It can create new business models. It can optimize your user experience, and it can create real, rich, local experiences. So we're going to go into kind of exactly which APIs you may want to use for certain use cases, and we're going to go into how you can actually get started using these APIs. So I'm going to jump on my computer here. How many of you have used the developers console? Good amount of you? All right, so this may be a little redundant, but we won't spend too much time on it. Can you switch over to the... There we go. All right. So using your Gmail account, you can log into the developers console. And if you're an organization that already leverages the cloud APIs or just different cloud infrastructure, you already have one of these projects. Like I said, the Google Maps APIs are just another place, another capability within this cloud console. So I don't have a project because I just created this account. And I'm going to open a donut shop somewhere because I like donuts. So I'm going to call this project Emily Likes Donuts. And I don't want emails. So while this project's being created, you can really leverage these in your organization kind of best by building them within, oh, I don't know why that happened. Well, that's okay, because I have another account that already has a project. That's okay. So you create a project, and it works, obviously. Um, so then it's going to take 2 seconds for us to start using the Maps APIs here. I've created a project, and I'm in the API manager. I'm basically going to go and enable the APIs that I want to use. You know what? This is why we have a video of the same thing. So let's just go back to the presentation. I'll just use the video. Oh, thanks. See, this is why I needed a joke. Handy. I have it recorded in a video, so. Yeah. Let's just go back to the presentation. I'm just going to show you guys a video of the same thing instead of doing it live. Okay, great. All right, that's good. No big deal. We don't need to show that. I'll just talk about it. So most of you have been into the Cloud Console, so unnecessary demonstration. You can enable the Maps APIs the same way you enable any of the Cloud APIs, Vision API, things like that. So to talk through my donut shop example, I would enable, let's say, the geocoding API, and I would enable the Places API. Sorry? Oh, it's okay. Don't worry about it. Thanks, though. Yeah, it's fine. I was just going to show you guys kind of how to do it. The point is, it takes 5 minutes. Like, if you're getting excited about using location data in your businesses, that's good, because you can leave here and you can start doing it in 5 minutes. You basically just generate something called an API key, which you then use to sign your web service requests to all of the Google Maps APIs. And this API key is kind of your signature as a developer. It tells us who you are. It allows you to actually track your web service requests. So when I gather my address data from my users that already order donuts from my shop, I would use the geocoding API to translate that address data into coordinates, which would then allow me to, again, kind of pinpoint my most lucrative areas. And maybe I want to open up a storefront there. So in addition to kind of finding out the densest customer population, I'm also going to use the Places API, which provides that like kind of really rich context data to locate existing donut shops or bakeries or coffee shops in that area. And maybe I want to find a place that is within a certain distance of my kind of loyal customer base to build a donut shop, but I want it to be at least, let's say, half a mile from the next bakery, right? I don't want too much competition right off the bat. I'm a starving baker. Is that like an oxymoron, a starving baker? Yeah, so those two APIs, I could start requesting that data right away. If I have my data stored, let's say, in the Cloud Console, I can build things that are integrated there to translate the data right away and start doing that analysis to open my donut shop. And then as I'm growing organically, or as I'm making those requests, as I'm building those services, I can track the usage in the API's console as well. So it's the same place, it's the same kind of functionality as tracking your cloud APIs, and it's very easy to use. We're going to skip all those. Yeah, so as mentioned, really, like, if you already use the cloud APIs, it's very easy to start using the Maps APIs. So you can start thinking about your location strategy. You can start messing around with your data and building that location context on top of your existing business data. You can start trying to find new ways to draw parallels between your business and location. All right, so here's going to be the meat and potatoes. And before we start out with the best practices, I basically want to tell you not to worry. Much like learning long division and then being handed a TI-89, you're really not going to have to do these in your development. There are client libraries that are out there in a few different languages that allow you to kind of implement these best practices when you're developing with the Google Maps APIs without having to think about it much. So we're going to go over them so that you have this kind of deeper knowledge. and you can be a pro. But we'll talk about the client libraries and how you can use those to kind of wipe your hands of it and know that Google is kind of helping you along the way. API key security. So we didn't get to generate an API key, but when you do generate an API key, the default security on it is none, which is okay, right? Like especially if you're just kind of messing around, if you're using it within your organization, if you're making requests to analyze data, you're probably not going to have anyone steal your key. In my time at Google, I think I've seen this happen one time, and it really doesn't matter that much because you can create a new project and you can create a new key. But it can happen, and like I said, your key is your signature. So think of it like someone taking you see these weird charges on your credit card or something. You're like, oh, I should probably like cancel this credit card and get a new one. Your API key is something that it is a best practice to secure. We love security at Google, so we do give you the opportunity to secure your API key. When you create a key, like I mentioned, in the credentials section of the developer's console, you can name it if you want. So I named it Emily's Super Secure Key. And you have the opportunity to restrict it to HTTP refers. So for example, if I'm building my emilylikesdonuts.com, where users can actually go order donuts from my shop, and I plan on using the JavaScript API, which is one of our web APIs, in that website to, let's say, build a store locator, I might want to restrict this key to only being able to be used from emilylikesdonuts.com. And that way, my competitor, BethanyLikesDonuts.com, can't find my key in my front-end code and start using it and using up my free quota as a standard plan developer, let's say. I can also restrict it to IP addresses. So for example, my server, if I'm doing a data analysis and I want to restrict it to certain IP addresses. And then I can also restrict it to Android apps and iOS apps using those app IDs. So this is definitely a best practice that we would recommend. Rate limiting. This is something that comes up all the time. Rate limiting in general is a principle that is existing in a lot of different APIs. It's essentially just limiting the number of requests that you can make in a certain number of time to each API. For the Google Maps APIs, in general, that's queries per second. In some of the APIs, such as the distance matrix API, it can get a little bit more complicated. So when you make a request to the distance matrix API, you actually specify multiple origins and destinations that you might be going to. And so in that situation, it's actually kind of based on the number of things you request per second. And you can find more details on that kind of thing in our developer documentation. We'll just in general talk about queries per second. And it's 50 as a default right now. And so businesses say all the time, why do you have this? If you want to be infinitely scalable, why do we have to adhere to this kind of thing? And our response is usually, okay, like let's work together to figure out what your expected QPS is, but it is really important to have that expectation. Basically, having that QPS allows us to do capacity planning for one thing, but it protects you and it protects your end users against something either, I was going to say how many of you have developed bugs, but you're not like super engaged with the hand raising, and I know you'd all lie to me. Everybody has developed a bug at some point, right? And so you don't want a bug in your system. Let's say we didn't have rate limits to use like 1 million queries per second, and your app goes down, and Google's server goes down, and the internet breaks, and you're sitting at your computer like, oops. So that's kind of the main thing. It protects end users across the board, and it protects your application, right? So if you have billing enabled, if you're like an up and running business, and you do pay for some usage, and then some kind of bug or maybe a malicious user that has taken your API key makes a ton of requests, that can be something that can actually, we would figure it out, and we would do all the googly things, like we would forgive the usage or something, but you get that charge, and you're like, what is this? So having QPS limits actually prevents some of those like hairy situations from happening. I'll just leave us here for a second. Yeah, so this is impossible because we do have rate limits, so you can't use 87 billion geocodes in 5 seconds. But yeah, we don't want this to happen. We don't want you to spit out your cereal. Error handling, all right. So again, when we talk about the client libraries that you can use to develop using the web service APIs, a lot of these things are handled for you, but it's good to know about them. So when you make requests to the Google Maps web service APIs, you get back something called a status code. And there's a bunch of these. They're kind of varied per API. Some of them have unique status codes. We're going to talk about the ones that are pretty universal across all of the Google Maps APIs. So there are some statuses that you want to see. This is usually the first thing you check for when you get your response from the APIs. An OK status is what you want. It's thumbs up. It means that you made a request that was recognized by our backend, and we provided you with data per your request. It's good. 0 results is still fine. It means that you provided us with a request that was legitimate, and we didn't find anything, and then we told you we didn't find anything. So for example, if I tried to geocode the Flintstones address, which is 301 Cobblestone Way, I think, if my memory betrays me, but I probably would get 0 results, or I'd be very surprised that we found it somewhere. So next, statuses where you want to retry the request. Over query limit has a lot to do with what we just talked about. So if you make too many requests within a certain time period, you're going to get this over query limit response. Like I said, usually this means QPS. You've gone over a certain number of queries within a second. But it can mean queries per day. So as a standard plan, which means basically a free user, non-enterprise user, you have a limited number of requests that you can make for free in a given day. So if you've exceeded that, you'll get this over query limit response. In that situation, you would basically want to retry the request after a period of time using exponential backoff. Basically, you keep retrying the request over an increasing period of time until you get a successful response. For over query limit, if you don't get a successful response after retrying, it probably means you hit that QPD limit, queries per day limit, rather than the queries per second limit. Unknown error is another response where you do want to use exponential backoff to retry a request. Unknown error usually happens because there was some kind of server error on our side. Sometimes that happens due to a high traffic at the time. So if you use exponential backoff, you maybe limit the number of times you retry, but you will eventually get an OK response, hopefully. Finally, we have statuses where you don't want to retry. Something was wrong, and retrying won't help. Request denied. So I mentioned API key security. If BethanyLikesDonuts.com tries to use my API key, she's going to get a request denied error. Or if I use an API key from a server, from an IP address that hasn't been whitelisted, like my domain was whitelisted, I would get a request denied error. Similarly, if I try to make a request to the Places API and I don't put an API key in, it's denied. It's basically something with your credentials that is incorrect or missing in this situation. Invalid request is also something where you don't want to retry the request. It means that there was something wrong with either the formatting, one of the required parameters was missing. So for example, if I try to geocode something like I don't even know, a bicycle, like not an address. If I don't put an address or a lat long or a place ID, it's gonna be like, what are you talking about? So invalid request means that there was something wrong with the request. In these situations, you should log them, and you should kind of try to identify the root cause. Even some of them you can programmatically fix, right? These are just things where you definitely don't want to retry them. There's actually a great video on our developer site. I believe it's right on the landing page for the geocoding API. But it talks about error handling and exponential backoff, specifically in context of the geocoding API. But as mentioned, these status codes are really pretty universal to all of the web service APIs. Mobile apps. So when you think of mobile apps, you probably think of developing in a native Android or iOS. We do have Android and iOS SDKs that you can use to develop on those platforms. But in some situations, it's better for you to use the web service APIs. Maybe if there is a feature or a piece of data that's not available through the native APIs, or if your use case just lends itself more to making web service requests. Maybe you want to do more with the data before you return it to the user's mobile phone. We generally don't recommend embedding your API key and making those requests directly from a mobile app. The best practice here is to proxy those requests through a server, and then using our client libraries, which we'll go over soon, build a server-side application that basically takes in the request from the mobile phone, queries the Google Maps APIs, gets back the data, does whatever you want with it, and then returns it back to the user. So as mentioned, the Maps APIs share the cloud platform. And the best way to do this is through App Engine, Compute Engine. It allows you to really use those services in the most integrated way possible. Now, these famed client libraries, we're finally here. I'm giving you the TI-89. No more long division. Most of the things that we just talked about are kind of handled through these client libraries. So these are open sourced. They're on GitHub. You can use them to develop that server application to either do the heavy-duty data analysis, leverage location intelligence, or to build the server-side application that's going to take in those mobile app requests and proxy them. They wrap the functionality of the Maps APIs, and so they're consistently updated as we come out with new features in the APIs to include that functionality. And as mentioned, they implement those best practices for you. So for example, rate limiting is handled inside of those client libraries, and you can set specific QPSs that you want to use. They're available in multiple languages, which is great for, I don't know, probably the developers here are like those quants who develop in like 14 different languages, but I'm certainly not. So I appreciate the fact that the languages are kind of varied so that I don't have to learn Go, even though that's like, everybody loves Go. It's really great because it allows you to develop in like the IDE of your choice and in a way that you'll be comfortable basically building and leveraging those APIs. As mentioned, they take care of rate limiting for you. So there's a default of 50 queries per second kind of built into those client libraries, but there is a way for you to set that yourself. It'll take care of exponential backoff and error handling for you. It'll handle signing your request with your API key so that it's not in your client code. POJO, so basically when you make a request to the Maps APIs, you get returned an XML or a JSON object, but using the Java client library, it'll actually translate those into usable objects. And the client libraries support both asynchronous and synchronous API calling depending on your needs. Cool, so I haven't been to the Code Labs area here yet, but there is a Code Lab on the client libraries. It's actually hosted by Brett Morgan, whose team built the library, so very knowledgeable. Like I said, you can leave here and you can in 5 minutes start using the APIs. Probably worth it to go to this Code Lab if you're interested in doing that and get some hands-on help with building these server-side applications using those client libraries. And if you don't do it, it's available online. You can do it at home. These Code Labs are really valuable. All right, so we've gone over a lot of stuff, pretty nitty-gritty stuff at some points, but you're probably at this point like, great, where can I find all this stuff online? You can. The Geo Developers blog is a really great way to stay up to date with these kind of specific things. The client libraries, I think, are relatively new, but there would have been a blog post telling you all about them and how great they are. We kind of have, across the Maps API organization, people contribute to this blog. And so it's just a really great place to kind of keep in touch. Our developer site is also a really great place to get technical documentation, sample code. You can probably build an entire application just by copying and pasting stuff from the developer site. That's what I do. It's also, like I mentioned, so the homepage will give you latest updates, videos, tutorials. That video on the geocoding API error handling was on the developer site. This is just kind of like the default place that you should go to find out information about the Google Maps APIs. The beta program, so this is another thing that is relatively new, but a really cool way to be the first person to be using certain features. And you can actually not only use new features in the beta program, you can directly influence how we build the APIs. I don't know if you're, so this is another nerd moment for me, but like, if I could, I mean, I work at Google, so that's not a good example. I can influence stuff, I guess. But if I didn't, it's really cool to be able to just be like, I contributed to this new awesome API. This is my feedback that has resulted in this result, in this feature that I'm able to use now. Yeah, it's a really great way to just be really directly connected with us. Awesome, so I leave you with that. Kind of get excited about using location data. It's very easy to do. There are a million possibilities of the ways that you can use it to enrich your business, and you can get started today. Awesome, thank you.